we present MEDiC, an autonomous surgical robotic assistance system designed to maximize exposure for dissection and cautery procedures. Shared surgical automation has the potential to alleviate strain on healthcare systems. We focus on one important skill within surgical shared autonomy, automating robotic assistance to maximize visual exposure and apply tissue tension for dissection and cautery. To do that, we take advantage of a differentiable physics simulation for tissue modeling and gradient computation to get the Jacobian information, which enable us to perform visual-servoing control. The visual exposure of a dissection site is quantified with angle and distance measurement. In addition, we develop an assistant position selection strategy for selecting the initial tool-tissue interaction position given a dissection goal. This strategy uses the Jacobian information from the simulator to look for positions that could potentially maximize exposure while results in minimum undesired shearing deformation. The proposed method's performance is tested extensively on real-world pork tissue and silicone phantom with the Da Vinci research kit. With a human-defined dissection goal, it automatically decides the optimal assistant position and expose the dissection site efficiently to aid dissection process. Thank you for your attention.